Ahí puso Joaquín de las declaraciones juradas. Entonces,
Pero
para
creo que
ver.
esas son las de físico, yo creo que no son las del CIBU, porque dice que firmadas con la pusieron solo, entonces no sé cuáles son, la de la física o la del CIBU.
Así, ¿verdad? Voy a preguntarle. No me
Chicos, por
acuerdo
cierto,
cómo se
cualquier
metió ahí.
cosa. Chicos, cualquier cosa, por cierto, hoy estoy en dos reuniones, entonces voy a tener la compu principal grabando y con la otra va a estar en la otra reunión a la vez, porque sí, esta carambada está como, si no hubiera tenido dos compus, se me dificulta grabar, entonces cualquier
Mm,
cosilla, voy a tener las dos compus al
Ok,
toque.
ok. Yo creo que ya todos están como cojos, ¿verdad?
¿A qué hora dejamos entrar a los demás?
Faltando 5.
Hello, finally.
Hi, good morning, 안녕하세요.
Yeah, sí.
Ya le pregunté a Joaquín si era con el SIGU, si era normal. Yo supongo que la del SIGU, pero la del SIGU, esa cosa no firma eso de una vez.
Es que por eso me quiero extrañar que ese Joaquín que difícil, como, bueno, que dice que con la pusieron solo, porque la del CIBU quedaba en una del sistema y nada más se definía como el visto bueno del Tanato, creo que es, porque como estamos bajo el del
Oh,
Tanato.
de él, creo que era. El visto bueno de él.
No, el visto bueno era de Tanato. Acuérdate que la vez pasada Joaquín tuvo que ir a donde William para que le diera el visto bueno porque parecíamos bajo él.
Bueno, ya le pregunté, esperemos a ver qué contesta, porque si es el de SIGU, eso se firmaba de una vez. No se ocupaba rúbrica. Y bueno, seguimos con 19 inscritos. Oiga, la gente así es. Viene número de identificación y ponen el nombre en el número de identificación.
Como siempre, no leí.
Cosa más terrible. Mira, yo no puse día sede de Punta Arenas. Así. Creo que la mayoría son chiquillos de Samuel. Son puras mujeres las que están inscritas. Bueno, después con la Muni.
Bien y mal. Bien porque sí vinieron, ¿verdad? Ocuparon el espacio. Pero de 17 personas solamente le llegaron 3.
¡Ah! De 17.
De 17 solo 3 le llegaron. 2 muchachas y un señor. Era para
San-
elaboración del currículum y solo 3 le llegaron. Y
Mm,
así dio el curso ella. Sí,
qué
qué pecado.
irresponsables.
Es que eso me está diciendo que como es gratis, ellos convocan
Mm,
gente y al final la gente no llega.
ese es el problema.
Sí.
Lo hice de nuevo. Ajá.
Sí, eso iba a decir que los voy dejando entrar. Entonces voy a estar aquí, pero no voy a estar. Voy a estar entrando para hacer capturas y todo eso, pero Voy a ver si puedo adelantar algo de la presentación, porque sí me preocupa que ocupo hacer esa otra. Tengo que pasar en inglés lo de la revista.
Recordá que yo con eso te iba a ayudar.
Ah, ok, entonces usted me puede ir ayudando con...
Sí, el
con-
miércoles yo puedo agarrar el día para ponerme a hacer eso. Legalmente voy a pedirle permiso a mi jefe mañana en la tarde para que ella ahí me dé un chancecito y el miércoles poder agarrar y hacer eso con tranquilidad sin que me esté presionando con otras cosas.
ah, ok, ok,
Sí, 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 porque
perfecto.
si no le pido permiso para eso, fijo, me va a estar presionando para otras cosillas.
Aquí es.
Entonces, con el paso de que hace tiempo que yo me levanté, todo lo que digo lo matemáticas, igual para mí que contemplé.
Buenas tardes, chicos y chicas. Ya estamos a punto de iniciar la lección de esta semana, tercera semana. Vamos a dar 4 minutitos más para que se conecten los que faltan y así podamos iniciar la clase. Gracias. Hello, everyone. We start in 5 minutes, please.
Okay.
Okay, thank you.
Do we start the class?
Yes, please.
Okay. Okay, hello guys. I hope you are having a great Monday at Costa Rica. Today, like I said, we are going to learn about the convolution neural network and about like image data processing, those kind of things. So today's conductor will be Sumin Han as last week. So let's go straight to the point.
Hello, I start. Please wait. Let's go. Let's start the class. If you look at the workbook uploaded together, there is a more detailed explanation. So it would be good to refer to it. Let's start it. Please download the MNIST and image file. You uploaded the Google Classroom before starting the class. Without this file, today's class cannot proceed. In today's class, we are going to study image classification, and we are going to image classification of ourselves. I hope you follow me well, and do you thumbs up when you completed the practice. Let's start. Do you know what about image? Image data is 2D arrays composed of small dots called pixels. Each pixel responds a specific color user-defined by RGB channels. Image data plays are crucial role in computer vision and analyze and proceed using various techniques. In the components of images, the components of image include pixel and color channel. Color channel have a RGB channel and grayscale. First, pixel are the smallest units of an image, with each pixel holding a specific color values. Color are responsive through RGB channel, with each channel ranging from 0 to 255, and RGB channel is each pixel trophically consistent of RGB channel, with each channel ranging from 0 to 255, and grayscale is an image with only brightness information without color. Constant of a single channel, values range from 0 black to 255 is white. Then image classification is a field of computer vision that aims to predict class of images. For example, given the dog and cat photos, there is a task of classifying each photo as a dog or cat. Image classification plays an important role in various real-world applications. The main application include the medical image analysis, autonomous vehicle, and face recognition and product classification. Let's learn about image classification methodology. Image classification methodology include traditional machine learning techniques and deep learning-based techniques. First, traditional machine learning techniques involve extracting picture from image and use using this feature to train classifiers. Notable methods include SIFT and HOG. Extract features are used to train classifiers such as SVM or KNN. Deep learning-based technique is with the advancement of deep learning. Conclusion neural network are predominantly used for image classification. CNNs has a neural network structure that can effectively process spatial information in image data. Let's find out the CNN. Conclusion neural network are a class of deep neural network that are primarily used for image and video recognition. CNN structure is the same as the image, and let's find out more about it through the videos. 잠시만. 소리 공유를 해야 되는데.
What is a convolutional neural network? Well, let's start with the basics. A convolutional neural network is a type of neural network that is most often applied to image processing problems. You've probably seen them in action anywhere a computer is identifying objects in an image. But you can also use convolutional neural networks in natural language processing projects too. The fact that they are useful for these fast-growing areas is one of the main reasons they're so important in deep learning and artificial intelligence today. Once you understand how a convolutional neural network works and what makes it unique from other neural networks, you can see why they're so effective for processing and classifying images. But let's first take a regular neural network. A regular neural network has an input layer, hidden layers, and an output layer. The input layer accepts inputs in different forms, while the hidden layers perform calculations on these inputs. The output layer then delivers the outcome of the calculations and extractions. Each of these layers contain neurons that are connected to neurons in the previous layer, and each neuron has its Once you understand how a convolutional neural network works and what makes it unique from other neural networks, you can see why they're so effective for processing and classifying images. But let's first take a regular neural network. A regular neural network has an input layer, hidden layers, and an output layer. The input layer accepts inputs in different forms, while the hidden layers perform calculations on these inputs. The output layer then delivers the outcome of the calculations and extractions. Each of these layers contain neurons that are connected to neurons in the previous layer, and each neuron has its own weight. This means you aren't making any assumptions about the data being fed into the network. Great usually, but not if you're working with images or language. Convolutional neural networks work differently, as they treat data as spatial. Instead of neurons being connected to every neuron in the previous layer, they are instead only connected to neurons close to it and all have the same weight. This simplification in the connections means the network upholds the spatial aspect of the dataset. It means your network doesn't think an eye is all over the image. The word convolutional refers to the filtering process that happens in this type of network. Think of it this way: an image is complex. A convolutional neural network simplifies it, so it can be better processed and understood. Let's look now at what's inside a convolutional neural network. Like a normal neural network, a convolutional neural network is made up of multiple layers. There are a couple of layers that make it unique: the convolutional layer and the pooling layer. However, like other neural
Recording
networks,
in progress.
it will also have a ReLU, or rectified linear unit layer, and a fully connected layer. The ReLU layer acts as an activation function, ensuring non-linearity as the data moves through each layer in the network. Without it, the data being fed into each layer would lose the dimensionality that we want to maintain. The fully connected layer, meanwhile, allows you to perform classification on your dataset. The convolutional layer is the most important, so let's start there. It works by placing a filter over an array of image pixels. This then creates what's called a convolved feature map. It's a bit like looking at an image through a window, which allows you to see specific features you might not otherwise be able to see. Next, we have the pooling layer. This downsamples or reduces the sample size of a particular feature map. This also makes processing much faster, as it reduces the number of parameters the network needs to process. The output of this is a pooled feature map. There are two ways of doing this: max pooling, which takes the maximum input of a particular convolved feature, or average pooling, which simply takes the average. These steps amount to feature extraction, whereby the network builds up a picture of the image data according to its own mathematical rules. If you want to perform classification, you'll need to move into the fully connected layer. To do this, you'll need to flatten things out. Remember, a neural network with a more complex set of connections can only process linear data. There are a number of ways you can train a convolutional neural network. If you're working with unlabeled data, you can use unsupervised learning methods. One of the best popular ways of doing this is using autoencoders. This allows you to squeeze data in a space with low dimensions, performing calculations in the first part of the convolutional neural network. Once this is done, you'll then need to reconstruct with additional layers that upsample the data you have. Another option is to use generative adversarial networks, or GANs. With a GAN, you train two networks. The first gives you artificial data samples that should resemble data in the training set, while the second is a discriminative network. It should distinguish between the artificial and the true model. A lot of people seem to be asking what the difference is between a convolutional neural network and a recurrent network. It's actually quite simple. Whereas a convolutional neural network is a feed-forward network that filters spatial data, a recurrent neural network, as the name implies, feeds data back into itself. From this perspective, recurrent neural networks are better suited to sequential data. Think of it like this. A convolutional network is able to perceive patterns across space. A recurrent neural network can see them over time. If you want to get started with convolutional neural networks, Python and TensorFlow are great tools to begin with. It's worth exploring MNIST dataset too. This is a database of handwritten digits that you can use to get started with building your first convolutional neural network. If you want to learn more about convolutional neural networks, deep learning, and AI, visit PAC.
Let's compare the technique covered earlier. Traditional machine learning techniques requires feature extraction and performance varies depending on the feature extraction method. Generally works well even with smaller dataset, and deep learning technique does not require feature extraction. The network automatically learns important features, excels with large dataset, providing the best performance. Let's take a look at the step to build an image classification models. First, prepare the data. Collect the collect image data and split it into training and data set. Data argumentation techniques can be used to increase the training data. Second, it processes the data, resize the image and normalized pixel values to transform them into a promise stable for model input. Third, we design the CNN model. Stack convolution and pooling layers to extract features and use fully connected layers for classification. First, we train the model. Train the model using the training data. Define the loss function and optimizer to update the model weight. Fifth, we evaluate the model. Evaluate model's performance using the test data. We used metrics such as accuracy, precision, and recall. I will do the image processing myself. Please turn on the Corel. Image processing involves various transformation tasks performed before feeding images into a machine learning models. This can enhance the model's performance. Let's upload the image first. You can see the Corel in image week 3-1 images. Corel notebook you have as this time code. You can refer to it. You can just run it. You choose the file and then you pick the Lena girl's image and open it. It's done. I will take your time. Next, we try to resize the image. Maintain consistency by resizing image of various size to standard size. You can see the second code. Can you learn it?
Can you show the code again, please?
Oh, okay. When you're done, give me a thumbs up. Next. Now we try color combination. Simplifies computation by converting color images to grayscale or using a specific color channels. I will give you time to learn it.
Vieras que me dio un error.
¿Cuál error sería?
Si quieren, puedo compartir pantalla para que puedan ver y...
Ok, Sam. Por favor.
Solo que no me deja compartir pantalla y dice que
Sí, porque están
eh,
compartiendo. Dame un toque. Showing Iceland has an error.
Yes.
Can he show us the screen? So I think you have to stop sharing.
Ah, okay.
This is just a moment. Ok. Ven, si gusta nos muestra, por favor.
sí, voy. Aquí está el error. Eso es lo que me está tirando.
Dice que imagen no está definido.
Pero yo lo abrí con el documento que viene en Google Classroom, entonces no sé.
Puedes subir, por favor.
Sí, voy.
Ok, si en paso 4 se declara imagen. Vuelve a ejecutar, por favor.
Este.
Ujú. Ok, suba y tiene que darle a elegir archivos. Ahí abajo,
¿Dónde?
más bien. Abajo donde
Aquí.
dice elegir archivos. No,
Aquí.
ahí, abajo el código.
Paleta de comando.
Abajo hay un botoncito como blanco, fondo blanco. Ahí.
Ah, ok. Ajá.
Ok, seleccione la imagen que ellos enviaron. Es lena.png.
Voy porque eso sí no lo tengo.
Ok, va a andar por ahí el asunto.
Voy a dejar de compartir un toquecito la pantalla y para buscar la imagen y luego lo voy a consultar.
Ok. Ahí la envió G1 también al chat. Por aquello.
Y en G1. Opa. Ahora sí, ya tengo la imagen.
Ok, entonces vamos ahí de nuevo.
Vamos a ver. Está material.
Ujú. Ok, baja un poco para
Dice que ya está bien eso, entonces.
ejecute ese otro entonces. Ok, y ahora el mando de error.
Ok.
Y
Sí,
ahora el de abajo, creo que de nuevo. Ok, y
listo.
el último.
Muchas gracias.
Gusto. So, can you continue, please?
Okay, I will start.
Thank you.
Now let's do noise reduction. Enhance model performance by removing unnecessary noise from image. I will give you time to learn it and then show the code. for this. Yes. CV2.Gaussian blur function is applies Gaussian blur to image A. If you lend us image, and then let's do a normalization. Normalization image pixel values to make model training more effective. You know the normalization? Normalization is converting data to specific range. I will give you time and show the code. Is the normalization. Now, let's do data augmentation. Increase training data and improve the model's generalization performance. I will take your time and show the code is too long. From now on, we will take a 15 minutes break and then proceed with the class. It's a break time. Yes.
Assuming I have a question.
Yes.
So in this last step, we generate new pixels for the image, is right?
Yes.
Okay. I can see a new background of the girl in the image. So it's very interesting.
Please, your question, give me a text chat. Sorry. Sorry. I'm sorry.
Okay, I will write my comment. Don't worry about it. Chicos, vamos entonces a un receso de 15 minutos. Son las 2:50, digamos, 2:48, pero digamos 2:50 y volvemos a las 3:05 y continuamos con la clase. Gracias. 3:05 volvemos. Okay, guys, see you in 15 minutes. Thank you.